without any further ado, to give our next presenter as much time as possible. Our next presenter has been at the forefront of open source security training for a really long time with some absolutely wonderful content that's freely available. Please give a warm welcome to Xeno, who will be talking about OpenSecurityTraining2.
All right, hello everyone. Happy to be here. This was me back in 2012, and thanks to low lighting and the magic of blurry videos, you can see that I haven't aged a day in a decade. So what was I talking about back then? I was talking about OST1, as I now call it, OpenSecurityTraining2. And what that was basically, at the time, functionally a hobby project. So minority of my time, but the basic idea was I was working for MITRE at the time, and they had an internal training program. I wanted to make sure that my classes didn't get stuck inside of MITRE and then died after I left, because I knew it wouldn't be there my entire life. So they had one of those policies that says we own everything you do, even outside of work. So I had to navigate through the public disclosure process and get my internal training released. And once I'd figured that out, then I could get a bunch of other MITRE employees' internal trainings released. And so that was OST1. And so basically, you know, up until I left MITRE, that was maybe 10% of my time maximum, just kind of hobby project on the side. I left MITRE, did a startup. The startup magically and mysteriously ended up at Apple. And I went into that knowing that if I go to Apple, I can't do anything with OST2, or OST at the time, because Apple's very tight-lipped, and I didn't want to bother with all of the navigating their public release process. But I also knew that if I did that, then when I left Apple, I would be able to spend all of my time on this. And that's exactly where I am right now. So at this point, OST2, the new relaunch that happened in summer of 2021, this is a proper 501c3 charity. This is to help differentiate us from the plethora of paid for-profit training companies. It's my full-time job, like I said, and I see it as basically a way for instructors, people who want to be teaching, want to be skilling up other people. I see it as a way to basically maximize their impact and teach thousands of people instead of dozens of students at a time. So I'm going to talk to you about the tactics and the strategy. We're going to start with tactics. How are we going to build out this nonprofit over time? The tactics is that we start by having an emphasis on quality, whereas OST1 was basically best effort, you know, even if there's only slides available, let's just throw it up on the website, something's better than nothing. Well, this time around, the basic idea is let's make sure that these are exactly the same quality of classes that you would get if you were attending a private training, if you're attending, you know, a corporate training. And so those instructors who want to do private engagements, they can continue to do that. They can make money that way. I'm at a point where I don't really want to do that, and I turn down things, but I still do actually do some conference training specifically to show other instructors that you can actually put your stuff available completely for free online, and people will still show up at your trainings at conferences. And my, you know, this is counterintuitive, the whole, you know, why buy the cow if you can get the milk for free. My recognition based on seeing the way that things work with real engineers, you know, as they mature and evolve into their career, eventually you get too busy to do a lot of stuff, right? You don't have the free time. You have, you know, family obligations, you have work obligations. So the people who are the typical audience for paid in-person training, they have more money than time, whereas the people who are the typical audience for free online training, it's your college students, it's your junior engineers who have more time than money. So it's a largely disjoint set, but you know, each set appreciates the availability, you know, of the other options. Okay, so I've budgeted 1 minute per class for myself to give you just a flavor of like the depth of these classes. Just to say, these are not like intro classes of like, let's spend 30 minutes showing you how to use Metasploit or something like that. These are deep classes. The minimum requirement is a day of class, where a day could be, you know, 6 hours, 8 hours, somewhere in there, because in practice, paid trainings, you know, a day is maybe 6 to 8 hours. So we're going to start with the symbolic analysis class by Tyus from Intel Storm. So this class, she talks about symbolic analysis, so satisfiability problem, and you know how you can represent things in Boolean logic, how you have theorem solving, stuff like that. And basically then first she starts with covering things like how to use Z3 in order to represent assembly language in a way where you can do constraint solving on that to find you know, what particular conditions would exercise particular constraints in some assembly language. Then she moves on to using tools like Anger. And so she does her class a little bit different from other instructors. She doesn't do slides. She does Jupyter notebooks and basically use the Python directly in the class. She'll give you a binary. She'll say, okay, here's the binary. The binary expects some sort of input. Now we're going to use Anger. We're going to use the Python APIs to figure out what are the expectations of this binary. So in this case, a little crack me that expects some magic password in. And so a normal reverse engineer would have to just eyeball that, read all the code, figure it out. And then learning tools like Anger for symbolic analysis let you go ahead and do all of that in a much more automated fashion, save yourself a whole bunch of time, solve CTFs way faster. She has a bunch of other stuff she talks about. Again, don't have time for it. Symbolic memory. Binary Bomb Lab is the thing in our assembly classes that we use. It's based on the CMU Carnegie Mellon binary bomb. And in our assembly class, we use the binary bomb and we say, here's how you're going to learn assembly. You're going to read a bunch of code, and that's how you'll reinforce your learning. She covers in her class, here's how you don't have to read a bunch of code, just learn how to use the tools to automatically solve these sort of problems. All right, then we have a C++ reverse engineering class by Gal. And in her class, she's looking at, take some tool like IDA, Interactive Disassembler, and if you're reading some code that happens to have been programmed in C++, then there's going to be things like C++ objects that are going to be in play. And the better that you understand the objects and the class hierarchies and stuff like that, the better you'll be able to apply semantically meaningful things to, okay, well, this is actually a name field of an object. This is an age field of an object. She covers things like inheritance, and there, the point is, in object-oriented languages, you have children and parents, and a child will inherit members and functions and stuff like that from its parent. And so she covers things like vtables, which are virtual function tables. That's the particular instantiation of function inheritance in C++, and then cover things like virtual function virtual function calls. And all of this really gets to just the point of, if you're a reverse engineer, there are C++ isms which you may not necessarily know if you're not normally doing C++ reverse engineering. I do reversing mostly on firmware stuff, mostly not written in C++. So I liked this class because I took this class as a student, and it's like, okay, I don't know these sort of things already because that's not what I normally encounter, and now I feel much more prepared if and when I encounter C++ in, for instance, kernel, for instance. Again, other topics I don't have time to cover, C++ templates and so forth. I have a class on Intel firmware attack and defense, and basically in this class I cover things such as how you can access the Intel SPI Flash memory mapped I/O interface. So they've just got some little memory region, and you've got to learn how to read their documentation. And if you have that, then you can say, okay, if I poke these memory locations in this order and I have particular things, then magic happens, and now we have SPI Flash reads and writes. This could be used defensively if you're doing firmware forensics to read out a SPI Flash. It can be used offensively if you want to break a machine. There's yeah. I was going to say, there's a talk tomorrow about UEFI and firmware breaking and stuff like that, but I have a full other class that talks about why you can potentially make it so that they're not bricked, because we look at things down at the hardware level. But the Intel firmware attack and defense class is really all based around threat modeling of what sort of defensive mechanisms that BIOS vendors need to apply. And if they don't do this, then everything is vulnerable. And so I expect that tomorrow's talk is very much about this. The green is a defensive mechanism. The red is a countermeasure that the attacker, counters the defense. And so it goes green, red, back and forth. If the BIOS vendor doesn't do every single green thing in this chart, then it's automatically going to be an exploitable BIOS where they can infect it, break it, and so forth. And again, other things, threat modeling for SMM, sleep-wake attacks. We have another instructor, Piotr. He is then building on top of this firmware. Like, that class was a x86, like firmware agnostic kind of thing. It's just how x86 hardware works. Piotr introduces things like UEFI. Now, at this point, I didn't know how to show his videos because it's mostly like a slide per video kind of thing. So I figured I'll show you, very quickly, like what it looks like to actually run around in a class on OST2. So it's videos, it's forums where you can ask questions, get them answered. You can track your progress. You can go do exercises. You can answer questions. So again, this is just to differentiate from OST1, where it was literally slap up some PDFs, slap up a YouTube video, call it a day. So now it's like an actual proper, like, reinforce your learning sort of environment. But then I did figure out how to make some videos, and so here's just a quick, like, 1 second per slide kind of thing for Piotr's class. talks about the basics, background of UEFI, the history, how things evolved, how the interface is used by modern firmware on basically every x86 system that you're using out there, and so on. And then, interestingly, Piotr and the 3M crew, Michal as well, they are big open source advocates, so they're big into Coreboot. Coreboot is an alternative firmware instead of UEFI, where basically it's fully open source. This is used on all Google Chromebooks because the founder of it works at Google. And so this is just sort of an alternative for those of you who are, big emphasis on open source and visibility into your firmware. Instead of having to reverse engineer things, you can start to just look at the source code. And it goes through, the different boot stages and how that differs from UEFI as we cover elsewhere. All right, and my final 1 minute through thing is the Vulnerabilities 1001 class. This has a very generic name because it actually has two different audiences that we're trying to serve here. This is both a secure development class, so it's called C family because we're saying this is vulnerabilities in C, C++, Objective-C, not PHP and Java and other things. And it's implementation vulnerabilities because we're not talking about logic bugs, we're not talking about command injections, we're talking about your traditional memory corruption implementation vulnerabilities that you would find in C programs. So Casey and I teach this class, and basically I taught this internally at Apple to basically say, dear developers, stop making the same vulnerabilities over and over again. My recognition from having worked with some extremely good vulnerability hunters is that over time, how do they find vulnerabilities? And my theory is that it's really just advanced human pattern recognition. So basically, they've looked at so many bugs over so long of a period that they can tell when something seems sketchy. They just know there's a pattern there. So I call this the sploity sense, and what I'm trying to do is teach vulnerability hunters and developers, to develop their own sploity sense and recognize the recurring patterns that occur over and over again. And so this is secure programming as you've not seen it taught by anyone else. This is basically focus on pattern recognition. So we cover a bunch of different examples, over 3 dozen examples, covering Stack Overflow, Heap Overflow, Integer Overflow, and so forth. And it's all about sort of breaking down some of the barriers to psychological acceptance by developers. And of course, the vulnerability hunters just want to check it out anyways. But barriers to acceptance are, for instance, if you're a firmware developer and I give you an example that's a browser bug, you're going to think, that's a browser bug, doesn't apply to me. So we're trying to split it up and show server, desktop, mobile, embedded, user space, kernel, virtualization, firmware to say, look, us security people, we know a buffer overflow is a buffer overflow, but it helps the developers to say, no, here's one that's really close to you and your code base. Furthermore, all the places that have little moon icons, those are actually 0 days that were caught in the wild so that they don't think okay, well, is this ever really happening? Do people actually exploit these? And then finally, the things with the little ninja next to them, this is again, developers in particular, they say, I don't think that's exploitable. That seems too complicated, too obscure, too abstract. And so one of the big things we focus on is walking people through the code. We show an attacker-controlled input, ACID, flowing through the code, propagating through, leading to under allocations, overflows, leading to actual exploitation. And so we walk people occasionally through the actual exploit because this is not an exploit class, but it really helps developers for their psychological acceptance if you can take them step by step by step, assuming absolutely no knowledge of assembly and say, here is exactly how an attacker would exploit this vulnerability. And then they say, okay, yeah, I get it. It's just a different type of engineering. All right, so just an FYI, if you're interested in that kind of thing, we have a beta test of the next class coming up in the next month or so. So check out these links. If you're a developer, you can go there, and if you're a hunter, you can go there. The Vulnerabilities 1001 is Stack Overflow, Heap Overflow, Integer Overflow, that kind of stuff. These are the new types of vulnerabilities that we cover in this next class. And again, it'll be starting in about a month or so. All right, so stepping back, that was tactics, okay? Take a breath. Tactics. Now we're going to talk strategy. So the strategy here is, okay, we've got a bunch of really technical classes. What are we going to actually do with those? So the most important thing is to build out learning paths where we take the classes, we sequence them, we figure out what the right ordering of prerequisites to follow on material is, and we say, what is the collection of classes that leads to a capacity to work in a particular job role? And furthermore, this is really important to me, I really hate when I see this wasted effort of people reinventing the wheel and every reverse engineering class teaching a little bit of assembly at the beginning, every vulnerabilities class teaching a little bit of assembly at the beginning. We need to break things up and figure out how can we reuse material to get the maximum bang for the buck here. So if, for instance, I'm trying to get students to like an architectural type role, like what I used to do at Apple, I got to say, how do I actually get them there? So I start with, okay, you need to know some assembly because you may need to step into a debugger at some point. If you're going to learn assembly, I consider the best way to do that to be able to read C source code and then look at the assembly for that source code, and that'll help reinforce it. Then if you're going to have to look at binaries at some point where you don't have the source code, you need to have a debugger in your pocket, whether you're interested in Linux, it's GDB. If you're interested in Windows, WinDebug. Then you cover things like operating systems internals for a particular platform, x86 in this case, but it could be ARM. We can build parallel versions of this for ARM and MIPS, everything else. But that covers the things like segmentation, paging, interrupts, port I/O, all Intel-specific things that virtualization, firmware, and operating systems people need to know about. But to actually do that as hands-on, you need to kernel debug your way so that you can look at a model-specific register. So we cover a more advanced kernel debugging class as well. Then if you want to get into that firmware class, well, that depends on some of that OS internal stuff that I mentioned, but we also need a simulation environment because there's things in firmware like system management mode or the reset vector where like the CPU actually starts at the 0th instruction. You need a full system simulator for that, and Symix happens to be exactly the one that Intel themselves use for pre-silicon validation. And that finally gets you to the point where, okay, now I can say you know something about firmware. Maybe you know also these other firmwares, UEFI and Core Boot. Now I can take you up a level, abstract it, and say it's not just about UEFI, it's not just about Core Boot. What are the design paradigms that everybody makes the same mistake over and over across all sorts of different firmwares? And that's the kind of thing where I've been lucky to have that sort of visibility. Now, that was build a system security architect. I've already got all of these classes built where I can now start building reverse engineers. Reverse engineers need to know assembly, of course. So we start from that. And then there's some classes, like Tyus's class on symbolic analysis, where that's it. That's all of the prerequisite that you have. You know assembly, you can go start doing Anger, and you're good to go. Now, what a lot of people think about when they think about static analysis is they think about the tools and learning the tools, things like IDA, things like Ghidra. And so we're going to be teaching these a little bit different here because the first assembly class, like I mentioned, we have a binary bomb lab. That's how we reinforce how to learn assembly. But I want to allow people who know they're trying to become a reverse engineer to immediately, right from the first assembly class, use IDA, use Ghidra. So we're going to be using those in the context of learn IDA, but also learn it how to use it as a debugger. And this is not exactly what a lot of people do necessarily, but it gives them the opportunity to immediately use it in the assembly class so that essentially I had to learn it the hard way. Things like GDB are not exactly user-friendly. I'd rather have people learn it an easier way with better tools like IDA right from the get-go. And the same thing for Ghidra. Classes like Gal's class on C++ reverse engineering, they have dependencies on things like IDA. She just assumes it away. She says, I assume you know IDA. If you don't, sorry, can't take the class. Similarly, she assumes you already know reverse engineering basics. She's just here to teach you C++ reverse engineering. So this is just to show that a instructor can like jump ahead, build a really advanced class, and we can worry about the backfill of like what classes do we need to get someone from 0 to that class. But for everyone else in the meantime, if you've got background skills, just jump right in and learn some new high skill. Like I said, I know reversing, I know IDA, but I didn't know C++, and so I could just jump right in, and maybe you can too. And again, this just then lets us build out more advanced classes. You can imagine in future worlds, we build things that are operating system specific reversing, language specific reversing. And now, final point, we've got a capability for reverse engineering. We can start building vulnerability hunters and exploiters. So we've got the vulnerability classes. We need a exploitation class, which is going to depend on something like reverse engineering so that you can look at, as you're trying to make your exploit, if you can't work in a debugger, you're not going to be able to make an exploit. But then we can build more advanced classes, like my colleague KC, he's going to build a class on end-day exploitation, so things where it's already patched, but you want to build an exploit for it. And then we have another person who's working on a class for Windows kernel exploitation, and this is an interesting case because he already had the class. He was already teaching it internally at NCC Group, but we said, okay, well, I want to take some of your material and break it up so that I can reuse your operating system stuff that you have to teach your students, and I want to reuse that class later on for other operating systems and systems architecture teaching. All right, so we've got a bunch of different learning paths where we can differentiate people and we can give them different skills. What are we going to do with that? Well, this is again where the long-term goal of open security training is figure out, what are the job requirements, what are the skills, and how do they actually map to different job recs, different names for the same job that every different company has. So I'm going to very quickly cover just an example of this for something I know well. Like when I was at Apple, some manager somewhere made a job rec to work on the team that I was on. If something is in red, that's not something that we teach at Open Security Training. Something like C programming, we don't want to reinvent the wheel. There's already college classes on that. There's already a bunch of other free stuff online, so you can find that elsewhere. If it's in blue, that's something that is in scope, so firmware, peripheral firmware. Those are the kind of classes we have for that. Then it calls out EFI specifically. Okay, we've got UEFI classes. It calls out Secure Boot. The 3M Dev folks already have a Secure Boot class that they're working on adapting for us. There are other things that might be on a job rec that is in scope for open security training, but we don't have an instructor for yet. That would be things like real-time operating systems. So if you know real-time operating systems, hit us up. Things like balancing concurrent priorities on tight schedules. Sorry, we're not teaching that sort of soft skill quite yet. Giving you a bachelor's, we don't teach that. But systems, kernel programming, and operating system internals, we have all that kind of stuff. So again, like I've done a bunch of these. I don't have time to go over all sorts of different ones, but this is just validation to make sure that the kind of stuff we're teaching actually is going to give someone a capability to, in this case, do a very high-paying job. But I know that my bias is showing here. I'm a firmware kind of person. I want to be clear, we're not only interested in all these system security type things. We're interested in everything. I started in network security and then moved to malware and moved to other places. So like we're interested in everything. Don't take my particular biases to mean we're not interested in mobile or crypto or anything else. All right, so future, here's some chickens. I don't want to count them because they haven't hatched yet, but these are the kind of classes that we do have instructors specifically working on right now. And the final point, I think I'm over time, is basically if you're interested in doing these kind of things, oh, well, apparently I have 5 minutes, so I guess I'm going to get questions. If you're interested in having a bigger impact than what you can do as one engineer doing one engineer's worth of work, you should consider teaching a class. So the thing that's like kind of crazy to me and the thing that made me feel that this is such a valuable thing to do that I wanted to leave my high-paying job and like do this for the rest of my life is like once I started doing OST1 back in the day, every security conference that I would come to and like talk at in like 2013, 14, 15, I would have people coming up to me saying, hey, I really appreciate OST1. That really helped me. It got me a better job. Every single instructor right now that is an OST2 instructor, there's someone who said OST1 helped me so much that I want to pay it forward and I want to teach a class now. So like I'm literally just building political capital in the background as I sleep, and I see that as like very valuable. Like I'm helping out a bunch of people, and someday those people might help me out. And so yeah, it's just, if you do the math, like the math to me is very clear. I can do one staff year worth of work every single year, or I can improve 1,000 people's work by even 1% over 10 years, and I've still done more improvement to the world than me doing just one engineer's worth of work. So pleasantly ahead of schedule, not according to my thing, but they gave me a little bit more time, so I appreciate all of your time. I guess I do have maybe a minute or two for questions if anyone wants to ask. Yes?
Can you hear me?
Yep.
So I have been trying to start a community around something, and a lot of people are, I think, only interested in that thing when there's a commercial entity or a vendor really involved behind it, and you seem to be a person that's really done something that I respect the shit out of. Very cool. But how did you move beyond what I see is a lot of people only do it? If so-and-so who's a commercial entity makes a trade or makes a tool, is it just like a personal reputation? Do you have advice for people who want to do things like this?
Okay, if I understood the question, you said you have a particular thing that you're trying to promote, and like, so I think you're sort of in this last thing. Like, you've got something where there's a commercial entity that's doing like a lot of training on a particular topic. Are you trying to promote the thing separate from the commercial entity? That's kind of what you're saying? Okay, so a non-for-profit's making a thing, and the commercial entity is also promoting the thing, and the question is, how do you move beyond like the commercial entity sort of training? Short answer is I don't know. So I think like when I put this second to last bullet here, like my feeling was essentially when you put the classes out there, like I was thinking people who have open source projects, people who have particular technology, you've got a little hobbyist board and stuff like that. Everyone has a new little hobbyist board. How do you break through the noise and stuff, right? And so like we've got, an audience of almost 10,000 people who are already signed up at the site. So they're already at OSD2 for other classes. This gives you sort of a built-in audience where like people who might not otherwise have seen your project or your platform or whatever, they can see it, and now you can like start to involve more people. But yeah, I'm out of time, so again, just hit me up around the con, just shout, yo, Xeno, and I'll turn and look. Thank you.